All right, so we're continuing on talking about this inverse function to the exponential 2 to the x, which we're defining as the logarithm function log base 2 of x. And we want to look at domain and range. So for our exponential function, remember that the domain is all real numbers or negative infinity to infinity, right? I can plug in any x. I will 2 to the negative infinity, 2 to the negative 10,000, to the positive 1.2 million. We will get answers out of this, right? But for the untransformed to the x, so no vertical or horizontal shifts, etc., our range, remember we have that horizontal asymptote, which we'll write as y equals 0. And then it goes to positive numbers, right? And hopefully you remember about the relationship of the domain and range between functions and their inverses, that the domain and range swap places, right? And that makes sense because x and y's are swapping places, right? So my domain for the log function for log base 2 is going to be 0, infinity, and which we see here, right? We have a vertical asymptote now at x equals 0, right? Up and down. And we have x values for all positive numbers here is what our graph is doing. And our range now is all real numbers, so negative infinity to infinity. Okay, so, and this is a little repetitive here. So definition of the logarithm function, when we have an exponential function, which is just going to be b to the x. For right now, we're using b greater than 1 to help us visualize and stay consistent, but it doesn't have to be. We could have b between 0 and 1. And we know for that exponential function that our domain is all real numbers, our range is 0 to infinity, that we have the y-intercept 0, 1 on the graph, and our asymptote is horizontal line at y equals 0. All right, so this is b to the x. Our inverse function, again, we're going to swap x and y. So we're going to get x equals b to the y, right? And in order to solve this for y, we have to define the logarithm function. So we are going to say y equals log base b of x. And the restriction here, of course, is that our base needs to be bigger than 0, which was true for the exponential. So this b is the same base as from the exponential function. And we need x to be greater than 0. All right, so we have those two restrictions on here. So this logarithm function, log base b of x, is going to be the number y such that x equals b to the y. So the argument of the logarithm is going to be the base to the power. So I always think of this as b to the y equals x, right? When we're thinking about doing this in our heads, when we do logarithms in our heads, more often than not, it is a good idea to just think about it in this form. X equals b to the y. All right, so remember here, our range has become our domain. So our domain for our logarithmic function is 0 to infinity. Our range is all real numbers. The point 1, 0 is on the graph, and our asymptote is x equals 0. Okay. And we'll go one more here because, again, I said that this was repetitive. So are these important? Yes, right? These are important concepts. So we know both functions are continuous. We can see that from these graphs here. There's no holes in them, no jumps. They are both 1 to 1, so inverses exist. And we've predefined the logarithmic function to be the inverse of the exponential, right? Our domain swaps with the range. Our range swaps with the domain, right? Exponential function has a horizontal asymptote at y equals 0, where our log function has a vertical asymptote at x equals 0. So these are your properties you should be familiar with those. So we're going to do some actual logarithms, evaluating, thinking about what they are in the next video.